Okay, I think, hello all. Hi,
Hello,
Lumna
doctor.
Mohammed. Okay, I think we can start now. Um,
Hello.
Okay.
hello, and then the others can join later on. So this session, well, thanks once more you all for joining this session. Um, we talked about vulnerability, and you're going to have a session with Lee on resilience. These are very important concepts, and in recent years, another concept has become increasingly popular in a broad range of inquiries, and this is cascading disasters, which we're going to look at now. So some of the things we are going to discuss in this session is the importance to understand what cascading disaster effects are, um, what terminologies are used or associated with them, how they can be studied, and most importantly, the characteristics of cascading effects or cascading disasters. So now, why do we study cascading effects or disasters? What is the importance of doing that? We all know that many systems nowadays provide us with fundamental functions and services such as power supply, transportation, healthcare, communication systems that have become increasingly interconnected. And as a result of that, there's growing dependency between the different societal functions that has given rise to these more efficient services. But what this means is that it has also introduced new types of vulnerabilities or dependencies between different systems, which means that if there's a failure in one system, it may cascade into other systems, giving rise to a number of consequences which may cascade and affect other systems. So studying cascading effects is important because in order to improve the emergency response to incidents involving cascading effects, to gain knowledge and understanding of the way cascading effects propagate between different systems in society and how these types of events give rise to negative consequences. So it's very important because most disaster managers professionals only think about the impact or effects of disasters as what we call the primary impact. They don't think about the long-term implications or how that can affect different systems in society. So now there's a number of processes which can be used to study cascading effects. There's a structured approach which can be done using historical data or official reports. So, and there are a number of steps that are also involved in that. The first step constitutes identifying systems that have been impacted either by the initiating event or through dependencies to one or several originating systems which have been impacted in an earlier cascade order. What we should note is that a single system may be influenced several times as it can be affected in several different stages of an event. For example, a certain system could be affected directly by an initiating event, but also indirectly through cascading effects due to dependency on another system. And of course, the second stage involves a method which is mainly to describe the dependency impact for each impacted system with a purpose to get an understanding of how and to what extent a system is exposed to strain when a system on which it depends has been impacted. And of course, the third stage is to describe the system impact for each impacted system, which refers to the effects on the impacted system due to one or several dependency impacts. So if you want to study cascading effects, basically you can, try to follow these three key stages. You identify the impacted systems, you describe the dependency impact, and also describe the impacts which happens. Now, definition of cascading systems or cascading disasters. Is there anyone who can think of a definition of what you think cascades can be, or your own understanding of it?
I can start with my example. I'm gonna take the 2011 Japan tsunami.
Yeah.
So describing a cascading effect, it started with an earthquake, then was followed with a tsunami, then a nuclear planet um, accident that occurred, and all the other implications of tsunami.
Yes, that is actually a very good example, because the nuclear plant was located very close to the sea, so already was very prone to any effects that may arise from other hazards. So that is a good understanding of it. But what about the definition now? It is interesting to know that there are no international vocabularies that specifically define what cascading disasters are, or are implied in the definition of disasters, unlike vulnerabilities and resilience. You don't have any standard definitions by the international community on those. But what is interesting is that if you look at the definition of disasters by the United Nations Office for the Coordination of Humanitarian Affairs, the definition is the cascading disasters is implied in the definition, because the definition shows that disruption could affect the functioning of society, as a whole, and imply that broader cooperation among different organizations and countries would be needed so as to provide the resources to cope with the event. So this is a definition which you can see. The other definition is by the United Nations International Strategy for Disaster Reduction. It is similar, but the key word in this definition, again, seems to be disruption, which implies that you can have an effect that can disrupt societal systems and functions. And this one introduced vulnerability as a fundamental element of losses. If you look at the standard definition, well, that seems to be the standard definition which is being used. The other definition is by the IPCC, the Intergovernmental Panel on Climate Change. And in this instance, the emphasis is on the relationship between the society and the physical event is given more weight. The interaction between physical events and vulnerability is taken into consideration. And this also emphasizes the need for cross-border emergency response. So if you look at the three definitions of disaster, the literature generally involves the interaction of natural and human systems, in which the latter could act as an amplifying factor. This requires a more dynamic understanding of the global interdependence of human, natural, and technological systems, which can produce hazards and disasters. So what this eventually means is that we have new vulnerabilities that are derived from increasing interdependencies between different systems. Now, there's a most recent definition of cascading disasters. If you read the articles which I told you to read, on the articles written by Pescorelli and David Alexander, they actually try to explain definitions of disasters. What I've just explained to you, that there are no international definitions on it, but this is a definition which they have given, which places emphasis on dynamics that are present in disaster systems. It also focuses on the failures that generate a sequence of events in the human subsystems, and also emphasizes the complex and multidimensional aspects of disasters that evolve constantly over time. So this is a standard definition. It looks rather long, but the importance is to pick out the key aspects of it. So there isn't any standard definition, but this is the one by David Alexander, which you have to take into consideration. And this definition actually emphasizes cascading effects that interact with other secondary and intangible effects of disasters. We are going to look at what we mean by intangible, or what we mean by tangible. Now, let's just look at some key terminologies or phrases that are associated with cascading disasters. We talk about cascading effects. This arises when an incident affecting one system or in society and propagates to another system. due to dependency in the system. An example would be an earthquake that causes fire, maybe tornadoes that cause drown power lines. You always hear, if you are reading a literature, about cascading events. So what are the events? You know, if, for example, as a result of a hazardous material spill, a neighborhood must be evacuated and a local stream is contaminated, these are also cascading events. Taken together, the effect of cascading events can be crippling to a community. They can actually affect a community. Another common terminology you see is cascading emergencies. And an example of that would be an earthquake that ruptured maybe natural gas pipelines, which could result in fires and explosions, which may dramatically escalate the type and magnitude of the event. There's interconnectedness of systems. An attack on one critical infrastructure, for example, can lead to cascading losses of services and financial consequences for government, society, and the environment. We've just talked about system being interconnected, the human system connected to the natural system, and there are, of course, different types of systems or functions which we are going to talk about later. Critical infrastructure, of course, is very key to this because when it is affected, it has very huge implications for the society. So that is a phrase which you find commonly when you are talking about cascading disasters. And of course, I'm sure that you have heard, or you always talk about direct and indirect impacts of disasters. The next slide, which you are seeing, describes the impacts of disasters as being direct, indirect, as being tangible and intangible, and also as being primary and secondary. I don't know if, have you seen these slides before? Anyone has seen this slide before?
No.
Okay, yeah.
No.
A secondary impact, some people can call them maybe the cascading effects, but basically the direct impacts are usually caused by the immediate effects of a disaster or the physical contact of a hazard event with humans or with property. For example, a bridge washing out during a flood, that would be a direct impact. When we talk about indirect impacts, we are referring to the ramifications of such physical contacts. For example, when the bridge is washed out due to floods, it may affect traffic, or there may be a delay in traffic that has to be rerouted, which may impact individuals, businesses, and public services, such as fire and police departments. So that will be an indirect impact, which is as a result of the primary impact. And talking about tangible and intangible, when we say that something is tangible, we are referring to impacts that can be measured in monetary terms. And if it cannot be measured in monetary terms, we can say they are intangible. So those are some of the words which you can use to discuss or talk about the impacts. But in most cases, people talk just about the direct impacts without mentioning the secondary impacts. Now, some few examples on cascading events. The slide you are seeing is the impact of cascading events on public health. If you look at it, you have deforestation and heavy rainfall that has caused floods. That may cause damage to crops. It may contaminate water supply, which may cause problems to the health systems. So generally, all the different effects may lead to increased health rate. And of course, there are so many things that may happen. It may cause maybe disease transmission after the disaster. Environmental considerations may be taken also. Endemic organisms. There are also population characteristics that are also involved in that. So basically, as a result of the flooding, it may lead to the outbreak of infectious diseases in the population. It may lead to population displacement. It may lead to environmental changes. And also, of course, so these are some of the things that may happen if you have one event. The other example there is on agriculture. So you may have a direct physical damage to agriculture. It may be a flooding event, maybe other events, maybe like a landslide that may impact assets. It may also impact the infrastructure, transport system, and natural resources. And this may cause losses across the food chain. And of course, that may affect, so many people. So the effects can actually have huge consequences down the line, and this may go on for so many years, which people cannot immediately visualize. So let's look at some of the key terminologies that are involved when we are talking about cascading disasters, especially in terms of systems. You have an initiating event or an initiator, which in this case is the first sequence of events that may happen. Maybe a flood may happen, we may have a fire that may happen maybe as a result of maybe a burst gas pipe. You can also have what is known as the originating system. Where does the impact or the events actually originate? A system from which a failure propagates to other systems is known as the originating system. And of course, there are so many, you may have different originating systems at the same time. You also have a dependent system, a system in which is negatively affected by a failure in another system. And of course, you will see when we discuss later that the human system is easily affected. For instance, you may have maybe power outage, or the power system is impacted, and then it's going to affect a dependent system, which may be maybe a railway function somewhere, if you consider that to be a system. And we've just talked about the impacted system, which is a system which is negatively affected by either an initiating event or an event affecting an original system. They also have the term dependency, which is a mechanism by which a state change in one system can affect that of other. And of course, we've talked initially about interdependency, the mutual dependency between two systems. For instance, like system A depending on system 1, system B, or system B depending on system A. But we are going to see examples of common systems in subsequent slides, and how these systems interdepend on each other. Looking at these terminologies from a disaster management perspective, multiple stakeholders and responders normally should be involved in managing cascading disasters. There's this analogy of toppling dominoes, which is commonly used to explain the cascading impacts of disasters, which some people may consider misleading, because it may be argued that disasters do not need to be conceptualized as cascades, which offer no particular challenge of understanding or managing them. So they appear to be circumstances in which vulnerability reduction strategies depend on the ability to develop a proper understanding of cascade. So, just talking about the domino analogy is definitely not enough, because we can put in place human systems that can actually mitigate that. And of course, other key terminology will be an incident, a chain of events affecting multiple systems, cascade order, there are different orders. So there are lots of terminologies which, if you have time, you can read and understand in order to understand cascading disaster or effects when you are talking about them. Lumina just gave an example of a cascading effect that occurred in Japan, and this slide is showing you different examples of events that happen in different parts of the world and the year, and the initiating events that eventually caused cascades in the systems. So you can look at it. Some of them you may know, some of them you may not know, but you can make an analogy based on maybe an event that happened maybe in Oman that is prone to hurricanes. So these are just examples of events that have happened in other places that have caused cascades. So now what we are going to do is to talk about the characteristics of cascading disasters or effects. The article which you were told to read by Alexander actually gives you examples of some case studies of cascading effects, different types, which you can read. So we're not going to focus on that. I think it is relevant that you have a broad knowledge of cascading, of the characteristics that constitute cascading disasters or their effects, which you can use in any study or in any explanation. And these are some of the characteristics which you are seeing, which we are going to talk about. And these characteristics are actually based on the study that was conducted in the EU that focus on an analysis of about 40 past events involving cascading disasters or cascading effects. So it actually gives us a very broad view or understanding of the different systems that are involved in cascading effects. And the next slide, which you are seeing now, are examples of functions that are prone to cascading effects, or what you can call systems, societal functions in the society. For instance, you can see power supply is a system, telecommunication, water supply, sewage, and so forth. So these are some of the functions in society that are easily impacted when you have a disaster and that are prone to cascading effects, and they interact with each other in the different systems to affect the different systems that are involved. So you can regard this as societal functions. You can also regard them as different systems. Now let's look at systems that are involved in cascading effects or cascading disasters. So if you look at the slide, if you look at the left, these are initiating events or the originating system. And then these are the dependency or impacted system. They realize that the systems on the left are the same systems on the right. So what this slide actually wants to show is which systems are more important as the originating systems, and which of them are more important as dependent systems. So in this slide, the originators, as I've said, are on the x-axis. So it is clear from the slide that the two most frequent cascading effects analyzed events are power supply and business. So if you look here, look at power supply, this here, this power supply here, and then you have business somewhere here. So if you look at power supply, you see that it's impacting most of the other systems here. Look at it. So in terms of determining whether power supply is an initiating event or a dependency event, you realize that you consider it an initiating event because of the number of times which it appears. So it can also be noted that power supply is often represented as the originating systems, and because this is represented many times along the row corresponding to power supply on the y-axis, as you can see here, and seldom as a dependent system. So you don't have so many of it impacting the other systems. So look at the public here. Look at the number of times the public is appearing on the slide. So the public is often represented as a dependent system, but it is also shown that quite frequently behavior of the public has an impact on the functioning of other systems, such as overloading telecommunication towers, maybe in case of emergencies. So this is a characteristic which enables you to actually determine which systems are easily the originating system, because of course power supply is a critical infrastructure. When it is affected, it affects so many other systems. So it's very important that if you are thinking about analysis that may involve maybe an event in terms of cascade, then you know that power supply can act as the originating system that might impact so many other systems. Of course, you can consider all of these other functions, as systems, and this is how they interact with the other systems. We cannot get into too much detail in explaining this, but what I think you should note is that one of the systems that is very prone to effects from other systems is the public. You see almost all the other systems affected in here. So it's one of the most common dependency systems, while power supply is an initiating event that may affect so many other systems. Most frequent originating and dependent systems. So if you look at this slide, the gray bars show the number of times each system has been represented in an analyzed event, and the blue lines in the slide illustrate the system impact. No, I don't think that is the slide. Okay, sorry. Okay, this is the slide. Yeah. So if you look at this slide, the number of times each system is represented as an original and dependent system, respectively, is illustrated. So this is the power supply system. Number of times it is represented. And just like the other systems, this is the public which is the most frequent dependent system. So this is, as I've said, based on the analysis. So the most originating system which affects other system is power supply, and the most dependent system is the public. So this is just to justify what was mentioned earlier. And then you can look at the other systems and the number of times which they're affected. So the next one is the frequency of system involved in cascading effects and the duration of the impact. So the question this slide seeks to answer is, how often are the systems involved and what is the duration of the impact on the systems? So you see that the gray bars show the number of times each system has been represented. Yeah, these are the gray bars. Each system has been represented in the analysis of the events, and the blue lines illustrate the system impact duration. So this is the duration. So the duration which different systems can be impacted actually varies. So some systems are more frequently represented than others. For example, the business and industry and public are the most frequent ones. This is the public. So it's affected most often. While the systems here like district, hidden, and the media are only represented a few times. Now, what is the relevance of this slide? It can be concluded that many systems have a mean value of impact duration around the range of 1 to a few hundred days. For instance, if you have something like oil spill, it may take a long time, for it to actually impact the system. While there are a few systems with significantly short impact durations, ranging from approximately maybe 1 to 10 days, like air transportation, sea transportation, and the media. So the result is very important because it gives an insight on different systems' ability to recover from disturbances. This is an indicator of their resilience, or if you mind, you can say the coping strategies, the systems. So this is the number of times the systems may be involved in the event, and then this is the system impact duration in terms of the days. And of course, the public is the most affected. Yeah. So what about the coping capacity of the system? If you look at the slide, the assessment of dependency impact level is compared with the system impact level for each system. So this is the dependency impact compared to the system impact. The dependency impact is blue, and the system impact here is black. So it can be seen that the dependency impact level leads to a higher system impact level, which means that the systems that are more sensitive to disruption with respect to other systems have less dependency impact level to the other systems. And the relationship, of course, is opposite. They are more resilient than the system that depend upon, as the average system impact level is lower than the dependency system impact level. So in order to understand this, if you look at this level here, this is the system or dependency. This black represents the system impact level, which is higher than the dependency impact level, which means that they were more resilient than the system on which it depends. And this also applies to the other systems. So from this result, it can be concluded that the coping capacity for different systems may vary considerable, meaning that some systems are less affected than other systems. So which means in the analysis of the system that can be impacted, you need to know the system that can be more affected and the system that can be less affected. So that is what this slide actually tries to show, which I don't think we have enough time to actually go into the detailed explanation. So the next slide seeks to explain the duration for the initiating event to impact different systems. So basically, how long does it take from the initiating event to impact in the different systems. So this slide basically shows the time delay between when the initiating event started and when a specific system was affected, which means that different systems can be affected at different times. Of course, it is clear that some systems may be impacted more or less instantaneously or immediately. For instance, systems like the public and the environment. And some can be impacted within 1 day. So if you look at oil and gas, if you have a gas spill, it may take maybe about 16 days. Some may take less than a day, like telecommunication system, power system, and then of course the media. Immediately, the public is almost immediately, almost 0 days. Public and the environment, as you can see. So what is the importance of this slide? What the slide is trying to explain that there is a time delay, that the time delay is important because it provides the window of opportunity for taking mediating actions with respect to an initiating event happening and the time to when system starts getting affected, which is extremely short for most systems in accordance with what the data actually shows from this research. So which means that if you know that a system will be affected immediately, then you need to take action immediately to deal with it, while the other systems that may take longer. That is the relevance for showing this, to give you a perspective of the different systems and how easily they can be affected or impacted. Another important aspect is the speed of cascading effects and or the rate at which they can propagate between different systems. The slide shows the time delay between when a specific system is affected in relation to when the system, it depends upon, are first affected. So this is also very important because for some systems, effects occur within a day. For instance, if you have a power supply and that impacts rail transportation, you have an immediate impact. While for other systems, it may take, there may be delays up to several days. For instance, water supply, if a source is contaminated, it may take some time before maybe affects areas that are downstreams. So these are the different times. Realize that air transport affects immediately, sea transport immediately. For instance, the volcano eruption that occurred in 2010 in Iceland, impacted air transportation immediately, and then of course that led to business interruptions all over the world. In fact, planes that were close to the source of the eruptions were actually diverted or sent back to their source. And of course, so many planes were discontinued. The flight were discontinued. So the impact is direct in some cases, and some cases it's not direct. So this is to give you an indication of the time delay between when you have an event and when it can start affecting the system. So it's just basically look at the different system and know the ones that can be easily impacted. And why is this information also important? It is important because it gives you a window of opportunity for breaking the chains of cascading effects and which systems that the effects may actually affect. So the next important characteristic is the size of the geographical areas that may be impacted by different initiating events. So basically, how large are the geographical areas that are impacted due to different events? So if you look at the slide, the impacted geographical area for some systems for each type of initiating event is given. If you look at landslides here, look at floods. If you look at the y-axis here, this is the impacted area which increases upwards. So those that are higher upwards will impact a higher area. So we'll normally expect that weather-related initiating events like hurricanes and heat waves tend to impact a large area, while some initiating events like maybe fires or volcano eruptions tend to impact smaller areas. So of course, definitely the figure shows a large variation in the impacted area between different cascades like landslides and in fact maybe small areas or even large areas here. And why events or hazards like volcano eruption, heat waves, and hurricanes, they may also vary significantly. But this basically gives you a perspective as to the space dimension of impacts that may occur from an event, and the area extent in which they can actually affect different systems. So basically, what we have tried to do is just to give you a perspective of the different key characteristics when you are studying cascading disasters or cascading events, so that if you were to write or to study them or to analyze, like in your essay, you can actually know or have a good idea of what you are dealing with, of what systems or societal functions which you can use and how they actually interact with each other. And of course, you now have a broader perspective of generally the impact of hazards and disasters and the extent to which their effects might go and the different systems in which they can affect and how the different systems can interact between themselves. So this last concluding slide is just like a summary of the things which we have discussed. So is there any statement, any question which somebody wants to ask? Hello?
No, doctor, from my side, it's okay. This is Mohammed. It's clear.
From my side, it's clear.
Everything is clear.
Everything is clear. So we still have some time, about 15 minutes more. So if everything is clear and you don't have any question, what I would suggest is that you just look at the material that was sent and you try to read the two articles. Actually, the first article, what David Alexander and the other co-author are trying to do from the first article is trying to explain what cascading disasters are and the definitions and the limitations in defining cascading disasters. I've explained in this slide, which actually comes from that article. And if you want to have more examples on cascading events, there are examples in that article as well. But if you have any subsequent queries, I mean, in a presentation like this, it is not possible to be very comprehensive, especially with regards to the different characteristics which I've discussed. But if you have any subsequent query or questions, always feel free to send an email to us and we'll try to explain. What the slides are doing is actually trying to give you a guide on how you can, conduct subsequent maybe research or guide you on your studies, when to look for materials or ideas on different themes which you can use. So if there's nothing more, I would like to thank you all for joining the session, and Lee is going to get back to you to reschedule the session on resilience, and then he's going to do that with you.
Doctor, excuse me.
Yes, hello?
Yes, doctor, just one question regarding resilience. We don't have so many sources on this e-learning system. We found about vulnerability and early warning and cascading. Only resilience we didn't find. Is there any suggestion to read something about resilience?
You find reading material on resilience. I think I put some reading materials there. I think there was some articles.
Not so many, only one or two only. That's it.
Okay, I'm going to, after this, I'm going to check, and I'm going to check and put at least 5 reading materials on resilience.
Yes, please, if possible, please.
Yeah, I'm going to do that immediately after this. So if you check Brightspace in the next 30 minutes, you're going to see there's material on it. I can assure you. I'm going to check and then add more.
Okay, doctor, very good. That would be appreciated.
Okay, thank you. Any other?
Doctor, I have a question.
Okay.
But it's not related to subjects. It's related to 500 words. It's mentioned there that we have to write do and don'ts, but which is actually what they have to do and what they not have to do during the hurricane, while actually you're doing the bulletin or the warning to the public, the press release. But do you want us to do it because there is a bulletin before and there's a bulletin during, there is actually instruction before the hurricane or while it's approaching and while it's hitting and while actually after the hurricane? Do you want to categorize 3 separate briefing or instruction to the public?
Well, I think basically, because that actually has to do maybe with early warning systems. It depends on how you actually want to do it. But basically, I think it will be good to focus on the things which you think is not relevant for people to do before the hurricane actually hits. Because things that will happen during the hurricanes, they are supposed to know before anyway. Okay.
Okay.
Yeah. So
Okay.
before the hurricane actually hits, what are the key things what are they don't, and what are they do? So you may focus on the things that they're not supposed to do before, because when it's already happened, then it's difficult to manage people. But if they already have a good idea of what they're not supposed to do before it, I think that would be good. So just focus. Well, in a real practical setting, all the three aspects are obviously very relevant. But for the assignment, focus on the things which they are not supposed to do prior to.
Okay, prior to. Okay, clear. Thank you, Doctor.
Any other issue?
Doctor, one very quick question, please.
Okay.
About the case study which we are choosing. I mean, they didn't ask us about which case study yet we are choosing, but if two people are using the same case study, is it okay, or it's a problem we need to change something?
Well,
or what?
ideally, you are not supposed to know what other person is using, is it?
Yes, exactly. So that is the main issue. I mean, if I'm using something and somebody else is using the same, and I don't know, but it's okay.
The restriction was on using case studies at any moment. So you can use a case study wherever. Even to use the same case studies, what we don't expect that the analysis is going to be the same. Okay?
Yes, exactly. Exactly. Yeah.
More convenient to you. I mean, you are free to discuss with their peers how to go on with the assignment, but please just try to be independent.
No, of course, of course. Yeah.
If coincidentally some other person is using the same case study as you, that's still fine. But the analysis will definitely be different, because the themes that you are going to be used may be different. You may decide to focus on durability or resilience, and the other person is focusing on cascading disasters and early warning systems. It depends on how you actually view the case study.
Exactly. Yeah. Very good.
Okay.
Thank you very much, Doctor. Thank you. Appreciate it.
Okay, ladies and gentlemen, thank you very much for joining the session, and we communicate subsequently on any other issues that you want us to talk about.